All right, greatest common factor. Okay, greatest common factor. Somebody explain to me what a factor is. What is a factor? Drew. Okay, it's a number that you use in multiplication. Okay, so by that then, if I say 3 times 8 is equal to 24, in that problem, 3 times 8 equals 24, which numbers or number is the factors? Celine. 3 and 8. So this is a factor, and this is a factor. Okay? Obviously, we've talked about that. Okay? We've just got out of a section 4.1 that we listed all the factors of the numbers. We prime factored numbers. So that was a stepping stone to what we're going to do today. Okay? So if you didn't get that down, then you need to make sure you come to tutoring. I'm in the cafeteria all week this week, so you can come up there and I'll help you with anything you need to help with. Okay, every day this week instead of our usual Tuesday, Wednesday, and Friday, I'm in there every day. Okay, so quit playing Clash of Clans or whatever you do with your little phones and your iPads and actually do your work. Okay, now, as we look at the greatest common factor, for example, if I had the two numbers 24 and 42, and I wanted to know the greatest common factor of 24 and 42. Well, one way that you could do it is we could list all the factors of 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Okay, I'm going to move my 42 over a little. Factors of 42, 1, 2, okay, 3, does 4 go into it? No, 5 doesn't go into it. 6 goes into it. 7 times, okay. 3 times 14 is 42. 2 times 21 is 42, and then 42. So if we look at which numbers are common, we know that the 1 is common because 1 is common with every single number. So if they have no other numbers in common, no other factors in common, 1 will always be the greatest common factor if there are no other factors in common. This particular problem, we do have other numbers that are in common. We have a 2 and a 2. We have a 3 and a 3. We have a 6 and a 6. Okay? So none of these are common with any of those. So therefore, our greatest common factor of 24 and 42 is 6. Okay? Now obviously, we've got to find an easier way to do that because we're going to run into some larger numbers. Okay? We're going to run into some larger numbers, and so we've got to have a shortcut to do that. Okay? The shortcut is the same thing that we sort of talked about yesterday when we talked about our prime factorization. The shortcut, or the way we find the GCF without listing the factors, is by using prime factorization. Okay, so let's use the same problem. We want to find the GCF of 24 and 42. Step number 1, prime factor both numbers using factor tree or inverted division. Okay, as I've stated, I will do both of them for a little bit here, but then we'll get into just where I do inverted division. Okay, but if we were prime factoring 24 using factor tree, that would be 4 times 6. 4 is not prime, so I go 2 times 2. 2 and 2 are prime. 6 is not prime, so I go 2 and 3. Okay, 2 and 3 are prime. Prime factor 42. Inverted division. 2, 21, 3, 7. Okay, so the prime factorization of 24, as I listed out, that's step 2. Step 2 is list in expanded form the prime factorization of each number. Okay, prime factorization, if we list the expanded form, what I mean by that is without the exponents. Okay, expanded form here is without the exponents. So 2 times 2 times 2 times 3 was for 24. 42 was 2 times 3 times 7. Okay, so number 3 is find the prime factors that are common to both numbers. Then list them. Okay, so what prime numbers are common in both prime factorizations? 3 and 2. Okay, so there's a 2 and a 3 that are common. How many times is 2 common? 1 time. So I use it 1 time. How many times is 3 common? 1 time. So I use it 1 time. So that would be 2 times 3, which is 6. Okay. So step 4 is multiply the common prime factors the number of times it is shared. Okay. Now, so let's look at these two numbers. Let's see here. There you go. 36 and 168. Obviously, we would not want to list all the factors of 168. Okay? 36 wouldn't be that bad, but we don't want to necessarily do that either. Okay? So, if we prime factor the two numbers, prime factor 36, so that would be 2 times 2 times 3 times 3. I just did it in my head. Okay, so obviously we prime factor it. using inverted division, that would be 2, 18, 2, 9, 3, 3. If you used factor tree would be 4 times 9, 2 times 2, 3 times 3. Okay, so that's where I came up with that. 168, I could do it in my head, but I'll show it to you on the screen. That would be 168, 84. Be 42, 21, 3, 7. So the prime factorization of 168 is 2 times 2 times 2 times 3 times 7. Okay, so next step is list the prime numbers that are common with both prime factorizations. What numbers are common with both prime factorizations? 2 and 3. Next is, how many times is the 2 in common? Twice. You have a common there and a common there. So I use it 2 to the second power. How many times is the 3 in common? 1 time. There and there. So I use it once. 2 to the second power is 4 times 3. So the GCF is equal to 12. Okay? Now, it doesn't change if I get 3 numbers. Okay? So, for example, if I want the GCF of 18, 30, and 60. Okay, 18, 30, and 60. So, I do the same thing. I still prime factor all 3 numbers. So, the prime factorization of 18 is what, Zach? In expanded form. Two times what? Yeah. 2 times 3 times 3. Noah, prime factorization of 30. 2 times 3 times 5. 60, Owen. 2 times, okay, times 3 times 5. Okay, obviously, factor tree or inverted division to come up with those answers. That's not our answer. That's just the process to get to our answer. Okay, now, list the prime numbers that are used in all 3 of them. Not just in 2, but they must be in all 3 prime factorizations. So, what's the first one in all 3 prime factorizations? 2. Times, what's another one? 3. Is there another one? No. 5 is only used in 2 of the 3, not in all 3, so we can't use 5. Okay? What is the most time that it is used? What is the most time that 2 is used? 1 time. Once, once, once. So I use it once. What about the 3? Once. There's 1 there, 1 there, 1 there, but there's not any more. So I use it once. So the greatest common factor is equal to 6. Okay. want you to do this one on your own. Greatest common factor of 48, 64, 96. I'll give you a couple of minutes to do that. All right. If you haven't finished it yet, continue to work. Okay? Prime factor 48. 2, 24, 2, 12, 2, 6, 2, 3. So 2 times 2 times 2 times 2 times 3. 64. 2, 32. 2, 16. 2, 8. 2, 4. 2, 2. So 2 times 2 times 2 times 2 times 2 times 2, 96. 2, 48, 2, 24, 2, 12, 2, 6, 2, 3. 2 times 2 times 2 times 2 times 2 times 3. Okay. Now, list the prime factors that are common. Okay, so which ones are common with each prime factorization? Drew? What? 2. And? Anything else? No. There's no other prime factor, so we don't list anything else. 3 is used in 2 of them, but it's not used in the third one. So, now we have 1 there. We have a second one. We have a third one. We have a fourth one. So I must use it 2 to the 4th power. Okay, 2 to the 4th power is what? So the GCF is equal to 16. Because 2 times 2 times 2 times 2 is 16. Okay, let's say we have this one. The GCF of 56 and 81. Okay, well, if we prime factor these, that's 2, 28, 2, 14, 2, 7. Prime factor 81. Can we use 2? No, have to use 3. 27, 3, 9, 3, 3. So 2 times 2 times 2 times 7. 3 times 3 times 3 times 3. Are there any common prime factors with both prime factorizations? No, there is not. No common prime factors gives us a GCF equal to 1. Okay? Now, I want you to get together with your row. Don't move the desk. I want you to get together with your row, and I want you to look at problem number 28, and I want you to come up with the answer. Go. You got 3 minutes, 4 minutes, 3 minutes. Maybe not even that. Yeah, you got like 2 minutes. Okay, real quickly, you're finding the GCF of those numbers, 108, 162, or 180, and 180. Okay, the greatest common factor of those is 18. So then you got to divide 18 into each one of those to find out how many is going to be in each basket. Okay? Your homework is 10 through 35. Use prime factorization on all of them. Don't list the factors. Use prime factorization on all of it. You may go.